I put this last problem as a conceptual problem to simply describe the essential difference between probability and statistics. We discussed this in class, and the slide is actually on the screen right now. The essential difference is the difference between what's known and what's unknown. For example, for a typical question in probability, what's known are the chances. You flip a dime 100 times, you know the dime is fair, and so you count 1 if it lands heads, you count 0 if it lands tails, and the question is predicting the future, what happens in a sample from this known population. In statistics, the question is reversed. There's a known sample, whether it's zeros or ones if it's a counting problem, or it might be a more general numbers if it's not a counting problem. And the thing that's unknown is the population from which it comes. The canonical example for this second example is survey work, where you survey a few hundred people to see who's going to be voted to be the next president. And assuming the lack of bias, which is a whole nother story, but assuming the lack of bias, then the sample is, we extrapolate from the sample to predict what will happen with the entire population. So in the probability problem, the population is known. What's unknown is the sample that is drawn from that population. In statistics, it's the reverse. The sample is what's known, and from the sample we're trying to infer what the population looks like. So it's a subtle but important difference between a probability problem and a statistics problem, the role of which one is known and which one is unknown.